Welcome to part 3 of the video tutorial about pipeline pilot data functions by Discngine. In this video, you will learn how to transform a Spotfire dataset with a data function.
Pipeline pilot data functions can be used to transform Spotfire data tables by creating additional columns, additional rows, or new data tables. Multiple transformations can be applied with a single execution of a data function. In this example, we will create a new data table from an existing one. The pipeline pilot protocol we use produces clusters of similar molecules based on molecular fingerprints. Let's first examine the protocol. The first component will read the incoming data flow from Spotfire. The SBDF reader component can read any binary objects from Spotfire, including chemical structures. The chemical structures will be then clustered by this component. A cluster ID will be associated to each molecule. The last component generates the data set containing the clustering information, which will be loaded in Spotfire as a new data table. The protocol exposes different input parameters. The source parameter will get the incoming data flow from Spotfire in the form of a SBDF file. The fingerprint parameter determines which type of molecular fingerprint will be used to compute the similarity. The average size of clusters, the performance setting, and the molecule identifier can also be set. After registering this protocol as a data function, users can use it in their Spotfire document. On this panel, the user can map data functions parameters. The first parameter should point to the column containing the molecules. The second one will be used to set the fingerprint type. Other parameters can use default values. After the execution, a new data table containing the clustering information will be added to the document. We can use a bar chart visualization to display the cluster sizes.
In the next video, you will learn how to use pipeline pilot data functions to create an interactive dashboard for end users.